Hello everybody, my name is Marcelino Varas. I'm product manager for Prevision in the areas AUTOSAR system, software and communication design. The topic today is combined AUTOSAR systems in Prevision. Let's take a look on the agenda. We will make a definition of combined systems. Then we will go through the design workflow for combined systems, which is proposed by Prevision. And at the end, we will take a look on the roadmap for the next versions of Provision with the features which are um, related to to the design of combined systems. Then, what is a combined system? A combined system is a system where we have several different technologies running on. For example, we will have different components where AUTOSAR Classic is running, but also components where AUTOSAR Adaptive is running. And why not, we will have also other technologies which are not AUTOSAR. We have also different communication technologies running on. For example, service-oriented communication realized on an Ethernet cluster using the SOM-IP protocol, but also signal-oriented communication, also in Ethernet, but over a gateway with a connection to CAN, CANFT, LIN, and FlexRay buses. Those several technologies are not only distributed on the system, which is in this case is a vehicle, but they may also be present inside of one ECU. So we have ECUs or machines which are our high performance computers where we will see several microcontrollers and microprocessors which are multi-core, and they can run different and several execution contexts. Execution context is a container for one operating system. That means one execution context may run AUTOSAR Classic, another execution context may run AUTOSAR Adaptive or some other systems, and that all in one high-performance computer. For sure, the possibility of the virtualization allows to share the resources which are available in this high-performance computer between the different execution contexts and with it the different systems. So let's take a look on this small example I have created with Prevision. I have the light blue boxes where I have put some classic platform. Then I have the green boxes where we have an adaptive platform. On the Ethernet cluster on this side, we are communicating with a service-based communication over Ethernet. In this case, we have another Ethernet cluster where signal-based communication is running. For this reason, we will need a translation between signal to service communication, which is realized on the adaptive side of this machine. This machine is a complex machine. It has not only one adaptive platform running, but also a classic platform and an Android system. Let's take a look on this server machine to see how it is detailed designed. The green box represents the machine which we have seen before. This picture is also realized with Prevision. It is just another layer where we can see the internal parts of one high-performance computer. We have the gray boxes representing execution contexts. As I said before, one execution context is the container for one platform or operating system. In this case, we have here an adaptive platform running in a Linux. We can also see the software components which are mapped into this execution context. which will also run in this adaptive system. On this execution context, we have an Android system also with some application components. And we have a third execution context on this side running a classic AUTOSAR. Also, we can see the software components which are running on. This box represents a hypervisor which brings a virtual switch which allows the communication between these execution contexts using this virtual switch. On the other side, the communication between execution contexts is also possible using IPC protocol. What we also can observe on this picture is that the microprocessor is also displayed, and the microcontroller, in this case the microprocessor, will host this hypervisor, and with it the different execution contexts 1 and 2. And on this side we see the microcontroller running the classic execution context. For the external communication, the different execution context and the virtual switch are connected to one further switch, which is a hardware switch, which has the connection to the outside world. So that is a example of high performance computer. We have different constellations and grouping of different components and figures in this kind of modeling. That is all available in Prevision, and just an example, but you can also design our own architecture of high performance computer. So let's take a look on the design workflow for a combined system, which is a proposal made in Prevision. We will see in this workflow there are common tasks. That means tasks which are common for AUTOSAR Classic and AUTOSAR Adaptive. Then we will also see that there are AUTOSAR Classic specific tasks, AUTOSAR Adaptive specific tasks, and we have a connection task, which is the task where we are connecting the different parts of the platform, of the classic platform, with the adaptive platform. So let's see how it looks like. In the case that we are working with a service oriented design, we start designing the services. This services contains or references service interfaces. That is a main artifact of one service based design. One service interface has properties, methods, or events. Then we have the definition of the service interface binding. That means the service interface will be bound to one some IP characteristics to be able to communicate on the bus system over the some IP protocol. Parallelly to this, or maybe already given, is the design of our network. In this case, we have a small topology here using switches, internal switches, external switches, connecting all inside of an Ethernet cluster together. And as you can see, these are all gray tasks. That means that are common tasks which are realized once, and they are available. The artifacts you are creating here are available for the classic design as well as for the adaptive design. Then we have specific tasks because the software components in AUTOSAR Adaptive are a little different from the software components in the classic platform. They have to be designed separately. So we have some adaptive software components which are typed, which have ports that are typed directly by the service interface. The classic software components have the classic interfaces like client server, sender receiver, and so on. We will see later how they will communicate together. Then we have one specific task that helps us to connect these two worlds, which are a little different. We will see it later on how. Then we have the next common task. Again, that is a gray task. The common task of mapping the different software components, which can be classic or adaptive software components, on the different machines and ECUs of the topology which we have. And afterwards, we will have also, and again, a couple of specific tasks when we are configuring the communication configuration and the creation of the signals and the methods of the communication are a little bit different for classic and adaptive. So we have in a classic side the service instantiation and the adaptive communication design, which is realized with a set of parameters, and with another set of parameters we create a serialization signal serialization for AUTOSAR Classic, and we have another set of parameters for configuring the AUTOSAR Classic stack. At the end of this design, we will get for the adaptive part the adaptive formats which are necessary. So we have an application description that is a format which is provided by provision containing all applications, all adaptive applications contained in a ECU and in one machine. In this application description are contained the specific design artifacts, but also the deployment configuration. Or we can also export a manifest where only the deployment communication is included. That is one part of the model. The other part of the model, which is related to the classic ECUs, that will produce an ECU extract, which will be used for the configuration of the different classic ECUs which are present in the system. All based on the same model. So you are not modeling different parts for classic and adaptive, excepting for this specific task. You have all information in one model. For sure, all these artifacts which are created in this modeling task are not always created from scratch, but they can be imported using some AUTOSAR formats and can be included into the model and be used by the tasks that you are realizing here. So, for example, you can import some service interfaces which are used for classic and adaptive, or maybe you have a already described topology included in an AUTOSAR file, and that is possible to be imported in provision, and the artifacts which are created can be used for your own modeling task. Let's take a more detailed look on this software connection, because that is very interesting. How two software components which are different can be connected. So we have typical adaptive software component will have one part where we will directly assign a service interface. Service interfaces, as I explained before, have some methods, fire and forget methods, properties, and events. On the other side, on the classic platform, we have other kinds of interfaces. So we have client server interfaces, sender receiver interfaces, and trigger interface. But there is a correspondence between a service interface on the adaptive side and the different classic interfaces on the classic side. And this correspondence is described here. For example, one method of one service interface on the adaptive side can be realized by one operation of a client server interface on the classic side. Fire and forget methods are realized by data elements or triggers depending on the existence of arguments and the um, on the method. So if the method has an argument, it will be realized by a sender receiver interface with one data element. If the fire forget method doesn't have arguments, then it can be or will be realized using a trigger interface with a trigger. For properties, we need several ports depending on the features which are activated by the property. For example, for the get and set operations, we will have different operations on the client server interface. And for the notifier, that is a notifier event which can be configured on the property for example, triggering a notification in the case that the value of the property is changed, then you will have an event in this case, and this event is realized on the classic side using a sender receiver interface with a data element. At the end, the simple event is realized using a sender receiver interface with a data element on the classic side. And this correspondence can be used for the connection between these two worlds. I show now how. So we have again the two worlds, the two software components, and in the middle we have the so-called port adapter. This port adapter has the know-how about the service interface. In this case, I have taken the service interface and have assigned per drag and drop into this port adapter, this service interface. And the port adapter displays the ports which are derived from the configuration I have made in this service interface. So for the adaptive side, it will offer one adaptive port which can be directly connected to the adaptive software component, and for the classic side it offers a set of ports which correspond to the ports on the classic software component. Very often question is if this direction is mandatory. No, we can create this port adapter. We can swap it, and in this case we have the server on the adaptive side, but the server can also be on the classic side. That doesn't matter. It is also possible to have the other direction on the port adapter. Here, a more complex example using more than one software component. Again, here is the server side, again on the adaptive side, but that is not mandatory. And we have here two classic software components, here two adaptive software components, and they are connected by the port adapter. And this port adapter makes the communication between two software components which are naturally not compatible. It is adapting this communication. We can see here the mapping to the ECUs. This software component is mapped to one classic ECU, and this software component is mapped to one adaptive machine. Once these software components are mapped onto the ECUs or machines in the topology, provision creates automatically the communication, the bus communication between them, in the case that this bus communication is necessary. Some other communication will remain maybe internally, but in the case that a bus communication is necessary, that will be created by provision automatically. How provision this communication creates is based on the SOM IP description for bus communication. That means provision will create serialized signals for the services. That means every method or event will get one serialized signal. Provision assumes that we will use the SOM IP transformer for this service-based communication, and we'll create a PDU with a signal and put it in on the bus using the so-called PDU and signal transmissions, which correspond to the PDU and signal triggerings in AUTOSAR. And that is created automatically. Provision searches for the paths inside of the topology, and creates also the gateways, the gateway entries if it is necessary, in the case that a gateway is present between the two components that want to communicate, and that is realized by the signal router in provision. The signal router is a algorithm which is in charge of creating the signal paths from senders to receivers, and for the Ethernet and service-oriented communication, it also creates the necessary PDUs for that. So that is the way how this unified communication is created in provision. At the end, as I said before, you can derive, or you can export from this model the correspondent AUTOSAR files to give to the next design tool or development tool of the vector toolchain. For example, the adaptive tool suite for adaptive and the configurator pro for the classic ECUs. So then that was the design workflow for combined systems. Now a short look on the roadmap so that you are aware about the features we have realized in provision 9.5, which has been released at the end of 2019. We have included the support for the AUTOSAR adaptive version 19.3. With this version came up the C++ data types, which are in provision also present and can be used for the adaptive design. Also in the adaptive side, we have extend the support to have the end-to-end protection configuration. And we have also make some extensions for the support of combined systems. For example, this port adapter, it came up with provision 9.5. In provision 9.5 service pack 3, which will be released in August, that is a small mistake here, that will be released in August. We will have available a Franca import and export. Franca is the IDL of Genevi, and it is a language for the description of service interfaces. In provision 10.0, we are planning the export of signal to service mappings, which are already available in the modeling. So we can create this signal to service mapping in provision today, or with the version 10.5, for example, but it won't be exported. And in provision 10.0, it will be available as a AUTOSAR import and export. So I'm ready with my presentation today. Thank you for your attention. You will have the possibility to to put some questions in the session Q&A. So I'm looking for, and I hope I will be able to answer all your questions. Thank you, and to the next time.